In the last video, we created an index binary data file using the random access file class to do it. The creation of the file and the code that would consume it would probably be different applications. I've got my project open from the last video, the random access project, and now that the index data file exists, I don't actually want to call the build method again. So the first thing I'll do here is comment out that statement that calls buildStudentData.build in my main method. I only need to build this file once, and now I'll write the client code that will make use of it. I'll start by writing code to load the index data first. For this, I'll set up a private static void method called loadIndex. This will take a random access file instance and an index position to start reading the data. I'll need a try block. I'll seek to the starting position, which in my case is really going to be 0. I'll call readInt to get the first data element, the count of records in the file. I'll print that to the console. I'll use that variable in a for loop to determine how many times I should read the ID and the file position. I'll populate my map using readlong to get the key and a second readlong to get the stored file position. And I'll add the catch clause here. Now that I have that method, I'll get back to the main method and set this up. I'll open a random access file, passing it the name, and this time the access mode just needs to be R for read. In this case, I'll only be reading the data. I'll call loadIndex, passing it RA and 0 as the starting file position to read that data. And I'll catch and handle the IO exception. To make this more interesting, I'll set up a scanner so that the user can request a record by inputting a student ID. I'll set the scanner up and prompt the user to enter a student ID or 0 to quit. I'll start a while loop using the scanner.hasNext method that returns a boolean. I'll keep getting input from the user until they enter 0. I'll use nextLine and pass that to long.parseLong to get the student ID they entered. If the ID is less than 1, then I'll quit out of the loop. I'll get the file position of the student from the map and use the seek method to go directly to that point in the file. I can use readUTF to get the record. I'll print the record to the console and prompt for the next ID. Before I run this, let me just talk to you about this readUTF method and the corresponding writeUTF method, which I used to write this data in the last video. Part of the functionality of the writeUTF method is to include the length of the data that was written. This means the readUTF method can first get that length and then read only that specified block of data into a string. Okay, so that's the code to prompt a user for a student ID and to retrieve that data. This code could be a lot more robust. It's possible the user could enter an invalid ID and this would throw an exception. I could use max and minute functions on the key set list to get a valid range, for example. For now, I just want to keep this short and simple to see if this actually works. I'll run it. I can see 1000 printed to the console. That's the number of records it found in the index, so the code was able to read that accurately from the .dat file. I'm being prompted for an ID, so I'll enter 777 and press enter. The code then prints the student data it found, and you can see this is right on the money, and it's printed the JSON data record for student 777. I'll try second student, so maybe 555. Now, I get student ID 555 and all of that student's data. This means I've been able to successfully load the index data, caching only that index in memory. I can retrieve records from the file on an as-needed basis and using a targeted file pointer to quickly do it. I'll press 0 to quit out of my application. Storing the index as the first part of a data file is one way to provide this information to your users. The second way is to store the index as a separate file altogether. I'll tweak the code a little bit and show you an example of this. Getting back to the buildStudentData class, I'll add an argument to the build method, a boolean called separateIndex. After this, I need to change the starting file position based on this flag. I use a ternary operator so that if this flag is true, my starting position to write the records will be 0, otherwise it will be the calculated file pointer. Remember that if the index is in a separate file, the records will be written at position 0 of the data file. The last thing I need to change is the call to the write index method. I'll first add a new line after the opening parentheses. I'm going to insert a ternary here too, again checking if separate index is true. If it is, I want to create another random access file with a suffix of IDX, and I need to pass RW here because I need to be able to both read and write to the index file from this code that generates it. I'll get back to the main class. I'll uncomment that line that will build the file. I'll change the first argument to just student so that my file names will be student.dat and student.idx. I also don't want to override student.data.that either. I'll pass true to that method now. I'll run this as is so that this code will create the separate data and index files. I'll also just quit out of the program right away by entering 0 at the prompt. My code will still be using the old data file to search for records. To see the new files in your project panel, you may need to reload from disk. But you should now see the student.dat and student.idx file in your project folder. I'm going to again comment out the line to build this data. I have to change my code next to use this new data file with its separate index. For this, I'll change the way I load the index data. I'll create a static initializer to load the index. You remember this is just a block of code at the class level that starts with the keyword static. I'll create a new random access file instance which will read student.idx, and my mode can just be read here. I'll call the load index method, passing it this random access file variable and 0 as the starting position. And of course, I have to deal with an IO exception. Now, I just need to go down to my main method. I'll change the name of the file from student.data.dat to just student.dat. I'll remove the load index method here. It's much better to load the indices once in a static initializer rather than any time this method is executed. Okay, so let's see if this works. I'll run it. I can see again that the load index method found 1000 records, and that's a good sign. I'll again enter 777. The application found the record in the new data file. This time, the index was built in its own file, and the record data is in a second file. This is a mini database now. I'll enter a second record, let's say 999, and there I get 999's record data. I'll press 0 to quit out of this application. Whether you include the index at the start or the end of the record's data file, or you maintain it as a separate file is really up to you. In this example, I've used a random access file to create a binary data file that contains an index mechanism to locate data records. I've also used a random access file to use this indexed binary data file to read data. These are only a couple of use cases for this type of class. You've seen that I didn't have to cache all the records, just the index. Another reason to use a random access file would be for targeted data modifications of a large file. For example, I could have found the record for student 777 and modified that record, for example. Random access files are also commonly used for binary data storage, as you've seen. Okay, now it's time for a challenge to put into practice what you've learned so far about random access files, so I'll see you in the next video.